have asked yourself these questions before. Why do certain reactions only happen when hot? Or why does ice spontaneously melt at temperatures above 0 degrees Celsius? What is so special about that temperature?
We are going to shed some light on these phenomena to better understand what's going on at a molecular level.
Good day everyone, we are
The Chemistry Legends, your science buddies.
And today, we are going to talk about chemical reactions. Specifically, we are going to talk about what the positive and negative values for delta H and delta S mean for the spontaneity of a reaction, Gibbs free energy, how to compute Gibbs free energy, and what the Gibbs free energy tells us about the direction of a reaction.
So first, we are going to begin with a short review of previous concepts. We are going to talk about systems. The system is whatever part is currently being studied, while the surroundings is the rest of the universe. The surroundings is what interacts with the system.
Hey Thomas, what are the types of system?
The three types of systems are open, closed, and isolated systems. An open system is where matter and energy can freely go in and out of the system.
A closed system is a system where matter cannot get in or out of the system, while energy can.
An isolated system, meanwhile, is a system where neither matter nor energy can go in or out of the system into the surroundings.
Among all the types of system, closed systems are important here because our lesson, Gibbs free energy, occurs within closed systems.
All these systems are reservoirs of energy, and the sum of all the types of energy found in a system is called its internal energy. The sum of a system's internal energy and the product of its pressure and volume is called its enthalpy. Enthalpy means the internal energy of the system and the work done to it. Delta H tells us the difference of enthalpy between the reactants and products. When delta H is a negative value, it means the reaction is exothermic and that it releases energy, and if the delta H is positive, it is an endothermic reaction and it absorbs energy from its surroundings.
And lastly, we are going to talk about entropy. Entropy is the measure of how much the energy of atoms and molecules become more spread out in a process. The universe always tends toward higher entropy or disorder or randomness.
Gibbs free energy is a thermodynamic property that predicts whether a process will occur spontaneously at constant temperature and pressure. The Gibbs free energy is the maximum amount of non-expansion work that can be extracted from a closed system. The Gibbs free energy equals the work exchanged by the system with its surroundings, minus the work of the pressure force. As such, it is a convenient criterion of spontaneity for processes with constant pressure and temperature. In chemistry, we refer to a reaction as spontaneous if no external energy is required for the reaction to occur. The formula for Gibbs free energy is this, wherein delta G stands for the Gibbs free energy, delta H stands for the change in enthalpy, T is the temperature in Kelvin, and delta S is the change in entropy.
We can compute delta H by using this formula, where we take the standard molar enthalpy of the products and reactants, multiply it by the amount of moles of the substance, and subtract the two to get the delta H value of the reaction. The table you see right now shows the standard molar enthalpy of several substances.
The change in entropy or delta S is defined by this formula. It is computed in the same way as delta H, except that we use the standard molar entropy instead of the standard molar enthalpy of a substance. This means we take the standard molar entropy of the products and reactants, multiply it by the amount of moles of the substance, and subtract the two to get the delta S value or the reaction. Shown here is a table with the standard molar entropies of various substances.
Hey Fritz, how do we determine if a reaction is spontaneous or not?
The value of Gibbs free energy shows whether a reaction occurs spontaneously at a given temperature. If the value of Gibbs free energy is negative, it means that the reaction is able to spontaneously go right. from A to B. If the value is 0, it means that the reaction is in equilibrium, and if the value is positive, the reaction is non-spontaneous, going right, but is spontaneous going left, from B to A. Using this table, we can see the relationship between the delta H, the delta S, and the temperature to the spontaneity of the reaction. As shown in the table, a negative value for delta H and a positive value for delta S means that the reaction is always spontaneous, because in any temperature, the value of the Gibbs free energy is always negative. Meanwhile, the opposite is true when delta H is positive and delta S is negative. The reaction will always be non-spontaneous because whatever temperature the reaction occurs at, the value of the Gibbs free energy is always positive. When both values are positive, a spontaneous reaction can only occur at high temperatures, because this is the only way T times will remain higher than delta H, such that delta G will be negative and the reaction will be spontaneous. Similarly, when both delta S and delta H are negative, temperature must remain low for spontaneity because, in this case, delta H must be higher than T delta S, so delta G can be negative for spontaneous reaction.
Our experiment for today will be the baking soda volcano. This is a very common experiment in which baking soda is mixed with vinegar to produce a volcano eruption-like effect. We will now turn it over to Lee to show you this experiment.
Hey guys! First of all, safety first. Don't forget to wear your safety goggles and gloves. For this experiment, we will need the following materials: 1/3 cup of baking soda, 1 cup of vinegar, plastic bottle, and a balloon. First, put the 1/3 cup of baking soda inside the balloon. Next, fill the plastic bottle with 1 cup of vinegar. Then, lift the balloon upright until the baking soda falls into the bottle. Lastly, wait for the reaction to occur and observe. The experiment shown in the reaction between baking soda and acetic acid found in vinegar and the chemical reaction is this. Sodium bicarbonate reacts with acetic acid, yields to sodium acetate, water, and carbon dioxide. We can see that one of the products of the reaction is carbon dioxide gas, which is responsible for the intense bubbling seen in the experiment. We will check the spontaneity of this reaction using Gibbs free energy to see if this reaction will happen spontaneously at all temperatures, low temperatures, high temperatures, or if the reaction isn't spontaneous at all. Note that this experiment was performed in a 25 degrees Celsius environment. First, we need to compute the delta H of the reaction. We will use the formula for delta H, then substitute the values needed and simplify. Delta H will be equal to 46.2 kilojoules or 46,200 joules. Delta H is positive, meaning that the reaction is endothermic and does not favor spontaneity. Next, we need to compute for the delta S. We will use the formula for delta S, then substitute the needed values and simplify. Delta S will be equal to 285.8 joules per Kelvin. Here we can see that delta S is positive, which favors spontaneity. We can see that both delta H and delta S are positive, which means that the reaction will only be spontaneous at high temperatures only. To see if the reaction will be spontaneous at 25 degrees Celsius, we need to compute the Gibbs free energy. We will use the formula for delta G, Then substitute the values of delta H and delta S we had just obtained and then simplify. Delta G will be equal to negative 38,968.4 joules or negative 38.97 kilojoules.
We can see from the Gibbs energy that at the room temperature, the reaction is spontaneous. The positive values of delta H and delta S also show us that the reaction will only be spontaneous at high temperatures.
For our second example, we will have the water in solid state or ice turning into water in liquid state. It is common sense to everybody that ice spontaneously melts into water. We will use the Gibbs free energy to solve it with the following given values. Temperature at 25 degrees Celsius or 298 Kelvin. Delta H is equal to 610 joules or 6.01 kilojoules. And delta S is equal to 22 joules per Kelvin. We will now solve for the Gibbs energy using these given parameters. We use the formula for delta G. Then, substitute the given values of delta H and delta S and simplify. Delta G will be equal to negative 546 joules. The Gibbs free energy value is negative, which means that the reaction is spontaneous. We can also deduce that the reaction will be spontaneous only at high temperatures because both delta H and delta S are positive.
Our next example is the same problem as the previous example, except our temperature now has been lowered to 263 Kelvin. We have the following given values: temperature at negative 10 degrees Celsius or 263 Kelvin, delta H is equals to 6010 joules or 6.01 kilojoules, and delta S is equal to 22 joules per Kelvin. We will compute for the Gibbs energy to determine if the reaction will still be spontaneous. We have the formula for delta G, then substitute the given values of delta H and delta S and simplify. Delta G will be equal to 224 joules. In this example, the Gibbs free energy is positive, meaning that the reaction is not spontaneous going to the right, but spontaneous in the opposite direction. This makes intuitive sense as water freezes by itself at negative 10 degrees Celsius.
And for our last example, we will determine whether the following reaction is spontaneous or not at room temperature. Nitrogen gas reacts with 3 moles of hydrogen gas, yields 2 moles of ammonia. Shown in this table are the given standard molar enthalpy and standard molar entropy of each substance in the reaction. Our first step is to calculate the change in enthalpy and change in entropy of the reaction. For delta H, we will use the formula for delta H. Then, substitute the values needed and simplify. Delta H will be equal to negative 92.22 kilojoules or negative 92,220 joules. The change in enthalpy is negative, which means that the reaction is exothermic and favors spontaneity. Next, we need to compute for the delta S. We will use the formula for delta S, then substitute the needed values and simplify. Delta S will be equal to negative 198.74 joules per Kelvin. The change in entropy is also negative, indicating that the reaction doesn't favor spontaneity. Now that we have delta H and delta S, we can now compute for the Gibbs free energy. We use the formula for delta G, then substitute the values of delta H and delta S we had just obtained and then simplify.
Delta G will be equal to negative 32,995.48 joules.
The value is negative, which means that the reaction is spontaneous at room temperature. Both delta H and delta S are negative, indicating that the reaction is only spontaneous at low temperatures.
Thanks for watching our video! We hope you enjoyed and learned something about chemistry at the same time. This is the Chemistry Legends! Your science buddies! See you next time! Bye-bye!